So today we are looking at day 6, which is special right triangles in our triangle properties unit. So you can turn your notes to that page and we're going to get started. So the first special right triangle is a 45, 45, 90 triangle. It's isosceles. Um, they are named based on their angle measures. So if we look at this first triangle here, it's isosceles. We know that it's a right angle down here. And question A says, what are the measures of the other two angles? Well, if we take 180 degrees for a triangle, we subtract 90, that is going to give us 90 degrees, and then we're going to split that between the other two angles, so each of them will be 45. Question B says, use the Pythagorean theorem to determine the length of the hypotenuse of the right triangle. So the Pythagorean theorem, a squared plus b squared equals c squared. So we're going to plug in our two legs, which are 1 and 1. And then we're going to just calculate that down to get c squared equals 2, and then take the square root of both sides. So our hypotenuse here is going to be the square root of 2. Not a super nice number, but that's okay. If we have a different 45, 45, 90 triangle, and the hypotenuse this time, the long side is 20, what are the lengths of the legs? Well, to do this, we can use the Pythagorean theorem again. So we're going to plug in a variable, the same variable for our two legs, because we know 45, 45, 90 triangle is isosceles, equals 20 squared. We'll calculate this down to a squared equals 200, take the square root, and we'll get that a is the square root of 200. So if our hypotenuse is 20, the two sides would be the square root of 200. Again, not a nice number, but that's going to be a pattern that you'll see when we're dealing with special right triangles. So looking at a couple of examples here, we're going to go through the first one, and then I want you to try the next two on your own. There are two properties of 45, 45, 90 triangles. The first one is that the legs are congruent because it's isosceles. The second one is that the hypotenuse is square root of 2 times as long as the leg. So whatever the legs are in a 45, 45, 90, if you multiply that number by the square root of 2, it is the hypotenuse. So looking at our first example here, you'll see exactly what I'm talking about. So our first leg is 7. And we want to find what x is, so this other leg here, well, the legs are congruent, so x is going to be 7. On the bottom, we have y, which is going to be the hypotenuse. Well, the nice thing about this being a 45, 45, 90 triangle is that the hypotenuse is whatever the length of the leg is times the square root of 2. So y is going to be 7 square root of 2. And that works for all 45, 45, 90 triangles. So what I'd like you to do is pause the video for a second, look at examples 2 and 3, and then we will go over them in just a second. Okay, so for number 2, you are given the hypotenuse, which is 11 square root of 2. And if you look up at our diagram here, the hypotenuse is n square root of 2, and n is the length of the leg. So this one is actually super easy. X and y are both going to be 11, because the legs will be 11. The hypotenuse is 11 square root of 2. For number 3, again, we have the hypotenuse is 18 here. And this one will be a little tougher because we need to find the legs, and there's no nice number in here, nice radical, like there was in number 2. So we can use the Pythagorean theorem, plugging in 18 and calculating it down to get a is the square root of 162. But it is no longer acceptable to leave that if you can simplify it down. So 62 is radical 80, 162 is radical 81 times radical 2. So your final answer for our, I don't know why I have a there, but x and y here will both be 9 square root of 2. The next type of triangle is a 30, 60, 90 triangle. And it's going to be made out of an equilateral triangle that's been split right down the middle with an altitude. And the nice thing about an equilateral triangle is that an altitude is also a perpendicular bisector, is also an angle bisector. So are these two triangles congruent? Yes, they are. By hypotenuse leg, you'd have the reflexive property for this piece here, and we know that the outside pieces are too. Part B says, what is the length of the shorter leg of each of the right triangles? Well, in an equilateral triangle, like I said a second ago, this is a perpendicular bisector as well as an altitude, so each of the bottom sides will be 1 here. And using the Pythagorean theorem, we want to find the length of this middle piece. So we will plug in to the Pythagorean theorem, calculate it down, and find that the middle piece here will be the square root of 3. So we have 1, 2 is the hypotenuse, and the square root of 3 is the third side there. So looking at some properties. For a 30, 60, 90 right triangle, the hypotenuse is twice as long as the shorter leg, and the longer leg is radical 3 times as long as the shorter leg. So it'll be set up like this. Your shorter leg is n, your hypotenuse is 2n, and n radical 3 is your longer leg. So what I want you to do is take a second and try all 3 of these. I would maybe start with 6 and work backwards 5 and 4. Okay, so for number 6, you are given 7 square root of 3 as the longer leg. That means that if you look at these two diagrams here, our shorter leg, A, will end up being 7. And our longer leg, B, is going to be 2 times 7, which is 14. For number 5, they give you the hypotenuse, which is 16. Well, we can cut that in half to get the shorter leg, A, which is going to be 8. And then our longer leg is going to be this shorter leg, radical 3. So 8 radical 3. And for number 4, we are given the shorter leg, which is 11. Well, we know that A is the hypotenuse, so that's going to be double that, so A is 22. And B here is going to be the shorter leg, radical 3. So B is going to be 11 radical 3. Your homework for today will be the day 4 worksheet. Actually, that should be the day 6 worksheet. I didn't change that apparently. So it will be the day 6 worksheet, not the day 4 worksheet. And I hope you have a spectacular day. I will see you later.